Hello friends, in previous video we discussed that algebraic structures with one binary operation. So in this video we discuss some examples on algebraic structures with one binary operation. So example 1 is let star be a binary operation on R. It is defined by A star B is equal to A plus B plus 2AB. So first question, find 2 star 3, 3 star minus 5 and 7 star 1 by 2. Second question, is R star semigroup? Is it commutative? Third question, find the identity element in R with respect to star. Fourth question, which elements has inverses? Here set is set of real number and star is applying between any two element is defined by addition of that two element plus 2 times multiplication of that two elements. So solution of first question, here we have to find 2 star 3. So by definition we have A star B is A plus B plus 2AB. So 2 star 3 is 2 plus 3 plus 2 into 2 into 3 is equal to 2 plus 3 plus 12 is equal to 17. So 2 star 3 is 17. Next we have to find 3 star minus 5. So 3 star minus 5 by definition 3 plus minus 5 plus 2 into 3 into minus 5 which is 3 minus 5 minus 30 which is minus 32. So 3 star minus 5 is minus 32. Next we have to find 7 star 1 by 2. By definition A star B is A plus B plus 2AB. So 7 star 1 by 2 is 7 plus 1 by 2 plus 2 times 7 into 1 by 2 which is 7 plus 1 by 2 plus 7 which is 14 plus 1 by 2. So 7 star 1 by 2 is 29 by 2. Now second question, is R star semigroup? Means આપણે એવું ચેક કરવાનું છે કે R with star છે એ semigroup થાય છે કે નહીં. તો એના માટે શું ચેક કરવું પડશે? First two properties. First property is closure property and second property is associative property. So we check closure property. So for any two elements from R, A star B is defined as A plus B plus 2AB. હવે આમાંથી તમે કોઈ પણ બે એલિમેન્ટ રિયલ નંબર લેશો તો એનો એડિશન પણ કેવો થશે? રિયલ નંબર. એનો મલ્ટીપ્લિકેશન પણ કેવો થશે? રિયલ નંબર. એને તમે 2 વડે મલ્ટીપ્લાય કરો તો એ પણ શું થશે? રિયલ નંબર. મીન્સ ફાઇનલી this form is also real number. Therefore A star B is also real number. Hence R is closed under star. Now we check second property which is associative property. So our claim is for any three elements from R, A star B star C is equal to A star B star C. So left hand side is A star B star C. So now we find B star C. હવે કોઈ પણ બે એલિમેન્ટ વચ્ચે સ્ટાર કેવી રીતના ડિફાઇન થાય છે? તો કે પહેલા એ બંનેનો એડિશન પ્લસ 2 ટાઈમ્સ એ બંનેનો મલ્ટીપ્લિકેશન. સો B star C is B plus C plus 2 into B into C. Now here A is first element and this one is second element and star is between them. So is defined as first element plus second element plus 2 times first element into second element. So is equal to A plus B plus C plus 2 into B into C plus 2AB plus 2AC plus 4ABC. Now similarly we find right hand side and finally we get left hand side is same as right hand side. Therefore, R is associative on star. Therefore, R with star is semigroup because these properties are satisfied. Now we check R with star is commutative or not and find the identity element in R with respect to star. So first we check commutative. So our claim is A star B is B star A for all AB belongs to R. If this property is satisfied, then R with star is commutative. So left hand side is A star B is equal to, by definition, A plus B plus 2AB. Now right hand side is B star A is equal to B plus A plus 2BA, which is same as A plus B plus 2AB. So left hand side is right hand side. Therefore R is commutative on star. Now we find the identity element in R with respect to star. So by definition, there exists E belongs to R such that S star E is equal to A. This property is old for every A belongs to R. Hence, E is called an identity element. So S star E is equal to A plus E plus 2AE is equal to A. A and A are cancelled, implies 2AE plus E is equal to 0. Now we take E as common, then E into 1 plus 2A is equal to 0, implies E is equal to 0, which is from R. So 0 is an identity element. Now we verify that 0 is an identity element. So we take, for any element A star 0 is equal to A plus 0 plus 2 into A into 0. So which is A. So here we see that A star 0 is equal to A for any element from R. Therefore 0 is an identity element. Now, fourth question is, which elements has inverses? So for that, suppose B is inverse of A. So by definition, A star B is equal to identity element, which is 0. So A star B is 0. So by definition, A star B is equal to A plus B plus 2AB, which is 0. Hence, B plus 2AB is equal to minus A. Now our aim is find value of B. So we take B as common, then B into 1 plus 2A is equal to minus A. Implies B is equal to minus A upon 1 plus 2A. હવે આ B ક્યારે એક્ઝિસ્ટ થાય તો કે ડિવિઝનમાં જે વેલ્યુ છે એ શું મળવી જોઈએ? નોન ઝીરો. ઇમ્પ્લાઇઝ B is exist if 1 plus 2A is non-zero. Implies A not equal to minus 1 by 2. તો કેવા એલિમેન્ટનો ઇન્વર્સ મળશે? તો કે R ના બધા જ એલિમેન્ટનો ઇન્વર્સ મળશે except minus 1 by 2. Therefore, every element has inverse in R except minus 1 by 2. Now, second example, so that the set of cube roots of unity forms a group under multiplication. So solution. So our first question is, what is cube root of unity? So cube root is nothing but solution of an equation x cube is equal to 1. If we solve this equation, then we get three values of x, which are 1, minus 1 plus root 3i by 2 and minus 1 minus root 3i by 2. So cube roots of unity is set G is equal to three elements 1, omega and omega square, where omega is second element minus 1 plus root 3i by 2 and omega square is third element, which is minus 1 minus root 3i by 2. So અહીંયા ગ્રુપમાં આપણી પાસે કેટલા એલિમેન્ટ છે? ત્રણ એલિમેન્ટ 1, ઓમેગા એન્ડ ઓમેગા સ્ક્વેર. તો આપણે પ્રૂવ કરવાનું છે G is group under multiplication. So this we can prove using composition table. સો કમ્પોઝિશન ટેબલ મેથડ આપણે ક્યારે યુઝ કરશું તો કે જ્યારે આપણી પાસે સેટમાં ફાઇનાઇટ એલિમેન્ટ હોય ત્યારે. કઈ રીતના મેથડ એપ્લાય થાય છે તો કે અહીંયા આપણે શું લખશું બાઇનરી ઓપરેશન વિચ ઇઝ મલ્ટિપ્લિકેશન. અહીંયા આપણે લખશું બધા જ એલિમેન્ટ સેટના તો 1 ઓમેગા એન્ડ ઓમેગા સ્ક્વેર. અહીંયા પણ શું લખશું બધા જ એલિમેન્ટ 1 ઓમેગા એન્ડ omega square. Now 1 into 1 is 1. 1 into omega is omega and 1 into omega square is omega square. Now omega into 1 is omega. Omega into omega is omega square. Omega square તમે find કરશો એટલે તમને શું મળશે આ એલિમેન્ટ મળશે -1 minus under root 3i by 2. Now omega into omega square means આ બંનેનો પ્રોડક્ટ કરશો તો તમને શું મળશે 1. Now omega square into 1 is omega square. Now omega square into omega which is omega cube, but એનો આન્સર તમને શું મળશે 1. Now omega square into omega square is omega raised to 4 which is omega cube into omega, but omega cube is 1 so remains omega. So this is composition table. તો અહીંયા આપણે બાઇનરી ઓપરેશન બધા જ એલિમેન્ટની પેર વચ્ચે આપણે એપ્લાય કર્યું છે. હવે આ કમ્પોઝિશન ટેબલની મદદથી આપણે ડાયરેક્ટ ઓબ્ઝર્વ કરી શકશું. સો કન્ક્લુઝન ફ્રોમ કમ્પોઝિશન table. First property is closure property. So it is clear that G is closed under multiplication because if we take multiplication between any two elements then we get element from G. Therefore G is closed under multiplication. Second, associative property. So we know that multiplication is associative in the set of complex number. Therefore multiplication is associative in G. Third, identity element. So from composition table we get 1 is the identity element. So કામ 1 identity element થાય છે કારણ કે 1 ને તમે કોઈ પણ એલિમેન્ટ થી મલ્ટીપ્લાય કરશો 1 into 1 is 1. 1 into omega is omega. 1 into omega square is omega square. એ એલિમેન્ટ પોતે જ આવે છે means 1 is the identity element. હવે આપણે ઇન્વર્સ ફાઇન્ડ કરવાનો છે તો 1 નો ઇન્વર્સ શું મળશે 1 because 1 into 1 is 1. ઓમેગા નો ઇન્વર્સ શું મળશે તો કે omega square. Why? Omega into omega square is 1 which is identity element. Omega square no inverse શું મળશે તો કે omega because omega square into omega is 1. So here 1 inverse is 1, omega inverse is omega square and omega square inverse is omega. So these four properties are hold for set G with multiplication. Hence the set of cube roots of unity forms a group under multiplication. Now example 3 show that the set of all positive rational numbers forms an Abelian group under the composition defined by A star B is equal to AB by 2 for all AB belongs to Q plus. તો અહીંયા set કયો છે set of positive rational numbers. It is denoted by Q plus and star is defined as A star B is equal to AB by 2. હવે આપણે પ્રૂવ કરવાનું છે કે Q plus છે એ સ્ટારની અંદર અબેલિયન ગ્રુપ બનાવે છે. તો એના માટે શું પ્રૂવ કરવું પડશે ક્લોઝર પ્રોપર્ટી, associative property, existence of an identity element, there exists inverse of all elements of Q plus and commutative properties. So solution, let G is equal to Q plus. Now closure property. So we know that A star B is equal to A into B by 2. Here A and B is positive rational number. We know that multiplication of two positive rational number is again positive rational number and divide by 2 is positive rational number. Therefore AB by 2 is positive rational number. Hence A star B belongs to Q plus. Hence G is closed under operation star. Now associative property. So our claim is A star B star C is equal to A star B star C. This property is held for every ABC from Q plus. So left hand side, let A star B star C. So now first A star B is equal to, by definition, AB by 2 star C. Now there are two elements and star is among between them. Therefore is equal to first element into second element divide by 2. So is equal to ABC by 4. Similarly, right hand side is A star B star C. So for S B star C is equal to B into C by 2. Now there are two elements of Q plus and star is among between them. Therefore first element into second element divide by 2 is equal to ABC by 4. So left hand side is right hand side, hence star is associative in G. Now third property, which is identity element. So by definition there exists E from Q plus such that S star E is equal to A. This property is valid for every A from Q plus. Here E is called an identity element of Q plus. So by definition A star E is equal to A into E by 2. So AE by 2 is equal to A, implies AE minus 2A is equal to 0. Now we take A as common, then A into E minus 2 is equal to 0. Now A is non-zero. Why? A is positive rational number. Implies E minus 2 is equal to 0. Implies E is equal to 2, which is from Q plus. So hence 2 is the identity element of Q plus under binary operation star. Now fourth property, existence of an inverse for each element of Q plus. So by definition for every A from Q plus there exists B from Q plus such that A star B is equal to identity element, which is 2. Now A star B is A into B by 2, so is equal to 2, implies A into B is equal to 4, implies B is equal to 4 upon A. So here B is nothing but inverse of A. So B is equal to A inverse is equal to 4 by A. Here A is positive rational number. So 4 by A is again positive rational number. So inverse is exist and it is from Q plus. Hence existence of inverse of each element of Q plus. Now fifth property, which is commutative property. So our claim is A star B is equal to B star A. This property is old for every AB from Q plus. Now left hand side, which is A star B, and A star B is nothing but AB by 2. Now right hand side is equal to B star A. So B star A is B into A by 2, which is same as A into B by 2. So here left hand side is equal to right hand side, hence star is commutative in G. So here all five conditions are held, which is closure property, associative property, identity element, inverse, commutative property. So these five conditions are held for abelian group. Then Q plus with star is called an abelian group, that is the set of all positive rational numbers from an abelian group. Thank you friends.